Right, looks like I'm up again. Dropping lots of frames. It's not liking this upload. Let me just see if I can do something about that. This has reduced the quality very slightly. See if that helps. Okay, seems to done. Just wondering why YouTube hasn't updated yet. I'm not seeing it. Oh, there we go. Now we're working. Okay. I think if I keep my computer really low quality on the monitoring of the stream, that might help slightly too. Hopefully. Right. Hi guys, yep, I'm back again. So I'm playing around now with screen capture, obviously. So I've got different views, so I've got this view here which I had before, so you can see you've got the HP sitting there on the bench now, and obviously close up that one, and there's the bench, so I've got different views set up for this now. I've used OBS a little bit for various things, not for live streaming me like this. I've done it for events I've worked at, for doing video feeds from the event, you know, looking out across paddocks, stuff like that, so I've done it for that sort of thing, but it's a little bit different. So we'll see how we go with this. So as you can see, I've got the manual open for this thing now, and I'm working through the issue it has. This is where I got it from, Arctic Media, which is, I think they've changed the name now to Arctic Manuals. I think they've changed the name. I need to increase my scroll rate somehow. So yeah, the manuals here, and it's, you know, from that company. They do really good quality scans. I mean, they scan the important pages really well. Like, you know, you can see the quality of this. It's pretty cool, isn't it? So what I've got with this is I'm trying to figure out what's going on with the bloody thing. Now, I'm not getting much progress yet. I spent a lot of time on it already, and none of you would have seen any video on that yet, because I haven't published any video for it yet. I think I said before, I've got about 70 odd bits of footage or so for that. Basically what it's doing is it's not reading anything, any values it's doing. It's just auto ranging, jumping over the place, trying to figure out what's going on. And I've been trying to narrow it down. It's got various test procedures and stuff in here. Let's scroll down a bit. Let's go this way, shall we? It's what I'm looking for: isolation of boards. So it's got these test procedures down here, which I will probably try and make a bit bigger so you can see it. So look, how's it's going to fit on screen? Let's do this. Make it a little bit bigger this way, shall we? Right. Too much. That's fine. I'll chuck it behind here like this. I need to shove that down a bit. Here we go. Right. Part of this is me playing the software as well, trying to figure out how to use it. So hopefully we're all good. Now the I've gone through a bunch of all these procedures. I've gone through all this stuff. Now it's even small for me on screen, so it's probably a bit small for you on screen still too. Let's see if I can get this a bit bigger again. Do it that way. Let's do that. Here we go. That's it's better. I'll minimise this so I get about the same view you're getting. That way it should be okay, hopefully. So we're going through these various procedures and checking through each stage, and I haven't actually found anything, which has been a bit frustrating. This is like test procedures here for doing. It's got internal switches, so you can set the switch and you can tell it to do these performance tests. So you test the digital board and the digital section, the analog section independently, and everything I've done has checked out. I haven't found anything wrong yet, but it's obviously got a fault. Power supplies are good. We'll go down to section here. So it's a pretty simple power supply system. You know, there's not a lot to it. So you've got plus or minus 12 volts, 5 volts there, ground, and you've got some reference information here. So 1.5 volt, 2.2 volt, I think it is there. Bigger. Yeah, 1.5 volt, 2.2 volt, and there's a reference here, and internal B. So I can't remember what that is actually for. But yeah, I mean, the voltage checks I've done have looked fine. I haven't seen anything wrong with the power supply. So as far as ideas go, I'm a bit stuck. So this is what I don't know how many hours I've spent on this thing so far. Probably a dozen hours, probably, working on this, trying to figure out what's going on with it. So here is block diagram. Let's get this out of the way here. So we'll go through the sections and sort of try and understand how it works, shall we? So this is the initial diagram here. So input sections, power supply, how the references in. So that's right, that's what that's for. 1.5 volt, 2.2 volts. So for the what's it called? Offset DC bias. Get the name right. DC bias. That says so right there. Look at that. So test frequency generation here. I mean, this is signal level stuff. That's where the capacitor goes when you're testing it. Is right there. That's the front panel terminals. It's basically got a differential voltage amplifier, and it's monitoring what's going on. Now the thing is, I don't know whereabouts in this whole chain the fault is right now. So it's being a little bit tricky. I've replaced a couple of parts and just put sockets in on a couple of ICs, and replaced some parts, didn't change anything, so I put the original part back in again, because they're probably okay after all. But yeah, it's hard to determine whether it's this analog section which is causing the problem right now, or whether it's something else. Yeah, it's driving me nuts, man. This is information about the ranges it can do, what you should expect and what have you. So I don't know. I'm not sure what else I can say about this particular part. Really, it's there's a fault here somewhere. That's what I know. I haven't been able to narrow down exactly where the fault is yet. And actually, it's been, I don't know, a couple of weeks, maybe a week or two, yeah, since I worked on it, and I actually forgotten where I was up to with it. So that's also not helping. That's a bit unhelpful, because I don't remember where I was up to. So obviously got a circuit theory here if you're interested in any of that. So it's got a digital section. Let's zoom out slightly. So it's obviously got the display driver, which is all that's all working fine. I've eliminated that. There's no issues on the display side of it. There's a couple of cards on display, and they've been alright. It's got this counter system, which is potentially a problem because multiplexed. There was something I replaced in the area. think it was U20 in this section here. I think it's one I replaced because I was suspicious of it. I think it's U20. And then ended up putting it back in again because it's fine. It didn't fix anything by changing that part. So the circuit theory on this is, yeah, I need to get my head around that theory too. So it's probably a bit premature for me doing a video on this because I don't actually understand it myself yet. But I want to play around live streaming. It's got timing diagrams, that sort of stuff's in here. I mean, I haven't gone down to this level yet. I may have to go down to this level to try and narrow down where the fault might be. Descriptions, all the labels, stuff like that. Come on, there's something else down here somewhere surely. So this is the testing stages, so you can do verification of operation. Remember rightly, I know it's looking at the wrong part of the manual. Oh, it's test procedures, sorry. There we go, test procedure stuff. What was that one? So I'll be doing test 1, test 2, which is analog and digital sections, and slightly. So test 1 is which one's which? I think test 1 is all the analog. I might have back to front. Let's see, I'm looking at the chat now finally. So yes, it's an LCR meter. That's right, it's the 4261A LCR meter from HP. It's quite an old device. And I did show it in a mailbag a little while ago actually, when it arrived. So yeah, I haven't made any progress on it. I've recorded lots of footage of me trying to find faults, find problems with it, but I haven't actually identified any definite problems yet, which is a bit frustrating. Simon Spears, who's got one of these things, he's repaired his one some time ago, and he commented when I was mentioning it previously that yeah, his was a bastard. So, yeah. Response about from iOS about the caps. No, I never did get a response from them actually. I think, yeah, I'm just really mindful about those. Was it Jack-On caps being bad, or being not the best brand? Let's check an email. Something just popped up. Right, cool. Yeah, so it's a bit of a concern that the branding they're using as their own brand, I suppose. They're calling it RS Pro, but it seems to be Jack-On is the brand they're using. That brand has had issues in the past. That's known for having a problem with quality control and faults, blowing very quickly, failing very quickly. So I'll use them as a last resort, but if I've got something better, I'll be using it. It's the way it is. Sometimes you haven't got a choice. In my country, the options for getting parts is limited. RS was like the biggest, and they are now doing more importing. So rather than being local stockers, it's importing from overseas. So you got long lead times. You got Element 14, which comes mostly from Australia. They actually are much quicker to get stuff, and the parts tend to be better quality in my experience. With the capacitor stuff like that, you get the same kind of quality as cats, but you can get their off-brand ones are actually better. Right? They tend to have the actual branded caps too of the styles which RS don't carry, especially an axial type. So that part's been better, but the yeah, so Element 14, unfortunately, you have to pay for postage, so it costs you more. I can't just buy 2 caps and have them turn up. I can, but it costs me a lot more money. RS has got free postage. That's the benefit there, and that's the only reason I use them. If the postage cost an RS was the same as Element 14, I'll be buying from Element 14 because they're faster, the caps are better. They've got a wider range. You know, it's just the postage cost is different. You know. Anyway, what we got there? So yeah, that's about right, Mike. Yeah, yeah. But if you look up the Jack Con is the name. If you look up that for on Google for problems, you'll see they've got a history of having issues. I can't remember exactly what was in now. I think it might have been computers, something it was in, and I'm pretty sure it was computer problems, blowing people's computers up, something like that. Yeah, but when I was looking for Jackon trying to find out what the hell this brand is, I came across that. I thought, oh, that's great, isn't it? That was some time ago, so they may have sorted their problems out. There might be perfectly good caps now, but I'm skeptical, very skeptical. Alright, anyway, so I keep going about capacitors a lot. Someone commented on my recent mailbags about spending half the mailbag talking about capacitors. It's like, yeah, I suppose I do, because I buy a lot of them. Because you end up replacing a lot of them. Hey, Mike. So, I mean, as far as this thing goes, the circuit theory is really where I need to sort of get my head into. Auto ranging is jumping all over the place, so this is probably a section where I need to pin down what's going on. But yeah, it's not exactly the easiest thing to go through. It's got lots of pages. It's a 211 page manual. So yeah, I really need to get my head around all this stuff, so I think I might just put that to one side for now. I mean, I may not work on this now. Let's switch to this. There we go. So yeah, this has been driving me nuts, this particular piece of gear. It's not the easiest thing to work on. Well, it's easy to get to. It's easy. I mean, I'll show you. I'll go to the bench. I'll show you. Right. So I'll come over here and I'll put a card out. Right. So let's pull out a card which will come out easily. Here we go. Pull this one out. Right. So dead easy to work on. Not a problem at all. Right. Easy to get to the stuff. These are conformally coated boards. Kind of. They're not. It's like a very light coating. It's not very thick, which is quite good because the thick coating is a real pain to work on if you're trying to resolder stuff. So, I mean, I've replaced this capacitor here. I haven't replaced those, I think. Or have I? Yes, I have replaced those caps there. So I've recapped everything, I think, apart from tantalums. I had some 15 UF tantalums, if I'm right, which actually arrived the other day. Maybe I'll do some video on that if I can find out where they are. Unfortunately, a couple of these clips broke when I was trying to get the bloody thing out, so it's not good. Got to try and wiggle this one now. That's now glued in place like this, so this is still got something to grab hold of. I've done those caps there. All the electrolytics have been replaced. I've done all that already. So you know, those are common failure points. I just did that as a matter of course, just to rule them out, because I couldn't find any faults. I just blanket replace. And yeah, I've done all those too. So all those caps are done. All those electrolytics. Heavy board. I spent a long time doing that. That's what a bunch of my other videos about is doing all that stuff. Replace the board there. This seems okay as well. Not much to replace on that apart from that one. And I think that's a chip there I did. There. That's one of the ones I did, I think. Yeah. That's right. 74LS74. That's why it's on a socket. Because I've already tried replacing that chip because I was suspicious of it. I was getting some interesting readings. Let's keep going through all the cards. I'm sure there's tantalums on there somewhere. I'm sure there was. Anyway. So I ordered some 15 UF tantalums. I'm pretty sure they're for this. Unless I've missed them. I don't know if they're. No. That's going to bug me now. Where are they from? So, power supply card. All those have been done. So I can't fault this card at all. It all seems fine. Oh, okay. Where the hell are the tantalums for? Because I don't see where they're going. Let's look on this card. This is a display card, which seems fine. Let's fold it over. Yeah, again, I've done all those caps already. So, can't fault that. So I mean, I've been, you know, when you go through and replace all the electrolytic caps, and that's like usually that'll fix 90% of the problems you find, and in this case it really hasn't. So something somewhere is wrong. I've been doing calibration stuff, playing with these calibrators. I think there was a couple I couldn't get right. Is it that one there? I think that one there I couldn't get calibrated correctly, which made me start following things through. One of these card has had some parts replaced already. Get the card back out again. Probably breaking up a clip in a minute. It's really fragile. No, it wasn't this one. I was tracing around on this one and I didn't find anything obviously wrong, even though I couldn't get this to set correctly. That was a little bit interesting. Which card was it? One of them had some transistors replaced. So probably what I need to do is go back to those and trace that back from there. I think it was this card actually. Yeah, this one here. Pretty sure. Was it? Yes. That transistor there and this one here had been replaced previously by somebody else. So that might be a clue to what's going on. So I'm just bearing that in mind at the moment just to decide if that's related to the current fault or not. But yeah, I need to get down a proper troubleshooting process on this thing at the moment, because at the moment I just don't have a nice method. Apparently I'm dropping lots of frames again on my stream. Well, that seems okay again right now. I also see that a lot of the YouTube stream health's looking bad. I saw it flicking yellow on my OBS program. Okay, hopefully it comes back. Problem with being on wireless internet, there's no broadband as such here. There's no wide broadband. There's no through copper lines or fibre optic or anything like that. There's nothing like that. I have to be on wireless broadband. So if there's any little interference nearby, it can knock it down a bit. If it's rain, it knocks it down a bit, and that kind of thing. Or if it's just got heavy workload, because it's wireless, if a lot of people get on nearby, radio interference causes it to drop down a bit. It's a pain. Anyway, so here's the fun of it. In case you haven't seen it yet. Yeah. But yeah, I've got lots of video footage already recorded for this, and I really want to get it fixed, but at the moment I haven't actually found what the fault is, and I can't remember what I was up to. If I can remember what I was up to, then I could at least carry on from that point. So, yeah, it's a pain. All right. Now what? What do I want to do next? Hopefully audio has a camera standing over there. I'll let you check that. It's not looking too bad. Yeah, okay. I put the mic kind of halfway between the two spots where my bench is, and which is over there, and where I'm sitting. So hopefully the game's kind of right for both spots. Yeah, I don't know. Anyone got ideas? Anyone got one of these things? Anyone had one of these? Which is actually, I'll show you the fault. Shall I? I'll power it up and I'll show you the faults. This looks like a band on it, so you can see what's going on. So there is a whole bunch of video I've already recorded for this, which I can show you. Well, you'll see later on when I actually publish it. Okay, power in there. I need to stand this up, don't I, so you can see the front. I want to pop this up. There you go. There's a crappy old gel cell battery. Just use that. That might be enough, eh? Right. Barely enough. Let's move back a bit further. That's alright. Now, it doesn't look too bad in that particular state. Initially you think, okay, that looks like it's probably going to work. Alright, we'll just chuck some test leads on it and we'll do some testing, and I'll show you what it's actually doing. Let's find some appropriate leads, hopefully. Get untangled. Okay. Oh, look, it's backwards. I'll have to do it this way, don't I? Alright, so the test lead's on there. So let's chuck it on resistance and short them together. You'd like one? You mean one of these? Yeah. So, shorted leads, and it's having trouble finding it. Okay, go to different frequency, shouldn't matter. Series. Yes, this is auto ranging over the place. Actually, mind you, I'm in test mode. Let's turn the test mode off. That might make more sense. Okay, tries again. Alright, so it does look like it's measuring 0, right? If we put something in there, it doesn't work. So if I do an inductant, that looks like what you'd expect, really, right? 0, because there's nothing there. Then it jumps around a little bit. See it's jumping around? Anyway, we'll chuck it on a capacitor. Funny enough, I have one of these. It's a Nippon chemical at least, so. Right. Let's see what this does. So this is a 220 UF 400 volt. Okay, let's change capacitance mode, parallel, or signal to parallel. Can't find it. Okay, high voltage. Just not working. If I change frequency, it just more rapidly can't find it. Alright, so you know, basically it just doesn't work. Okay, so that's the problem. I tried doing capacitors. I mean, yeah, here's a different one. There's another one. It's another Nippon Chemical. This is a 270 UF. Again, can't find it. Just jumps everywhere trying to figure out what the hell it is. So it is reacting to the fact there's something there. So it's kind of doing something, but it just cannot find the actual values. So. It is a nice unit, yes, if it works. We get it working, it's great. So that's the problem I've got, is trying to get it working. I thought I had some other bits here I could test. I've got some bad caps here. Yeah, there's some caps I pulled out of this unit actually. Yeah, these are out of here. It's almost like cannibalism, isn't it, really? You know, it's testing the same parts. Check it out here. So nothing on that one. Can't find it. Do parallel in case it matters. No, doesn't do anything. So it doesn't seem to matter what size capacitor I'm trying to test with it. That's a 100 UF 16 volt. So it just doesn't go. So this is what I'm working on. A lot. Have I measured the output and the leads? Now that is actually something, that's a good point. That is something I was going to do. That I had crossed my mind. So yes, we can do that. I actually have my multimeter set up right here, right now. So if I adjust this camera slightly, like so, we have multimeter and oscilloscope in shot. Alright, so I can do either one. Just power the scope up and get a lead for that. It's behind here somewhere. Head in a shot again, probably. Right. Let's see what the scope thinks first. So yes, we have a waveform there. which is 121 hertz. So that's pretty close. And voltage, well, 5 volts. There's 5 millivolts division. So I'm getting the waveform's right away. 1 volt RMS, which is what it's set to. If I drop it down, we're now getting about 55 millivolts. So 50 millivolts, so it's 10% out, but not too bad. Bit of noise in there too. It's probably not helping. I think it's actually just light. Yeah, I'll turn that light off, it gets a little bit better. I'll turn the other light on instead. This one doesn't do it. So yeah, that's the output waveforms look correct. So let's try 1 kilohertz. And just having trouble reading that one. Probably there's a bit of noise in there. Probably there's some noise. Let's go high voltage again. Right around might help. Now it's measuring 1 kilohertz. So yeah, I mean the actual waveforms going to the jacks are looking correct. So you can't fault that. That's a good point too. Yes. Super Brian AK. I haven't noticed any blown parts or blown tracks. There's nothing obvious. Visually, I haven't seen anything wrong. I've obviously looked over the boards, and I've already done some repairs with replacing the electrolytics to try and see what's going on there. But I haven't seen anything out of the ordinary, apart from those two transistors on, which is that card there, being replaced already by somebody else. So they may be the wrong parts. I haven't looked into that part yet. I'm assuming they put the right parts in. You know, it wouldn't be the first time I found the wrong parts put in something actually. So that's something to be considered of. Oh God, I can say it. Something to consider. So the next stage in the sense circuit. Well, yes, it seems that way. I mean, the sourcing is there. The source waveform's there. You actually see just by me having that hooked up, this is trying to measure the scope. It's measuring the scope input, isn't it? Does it find anything? It'd be interesting, wouldn't it? Yeah, anyway, it's trying to measure the scope input, so it's trying to do something. It is detecting when there's an input, but it's obviously not looking right. So yeah, I mean, obviously the actual test signal which is being applied to the part is correct. That's fine. So at least that part there is eliminated. So I might try and find that back in the diagram, and we're going to have a look. Here we go, back to the window. Now I've hidden the bloody toolbar. Where's that gone? Is it that one? Yes. Right. So analog block diagram, we go back there. Nice and big so you can all see it, hopefully. Alright, so the sourcing section is this. So this is obviously working here, okay? This part here is fine. So what's happening then is it's coming through here to this device here, and then going through the sensing circuitry. So as it calls it, process amplifier. And that's where you change the mode, serial parallel mode here for these points. So this is actually switching these two sensing op amps. It joins them together onto this one here. If you're doing series and parallel, right? So yeah, interesting. I have to look into how that bit works actually. So yeah, it's something in here. I need to go through the circuit in a logical way check each stage. So this is the A5, which is this thing here. And I've gone through a bunch of this and done these waveform checks. Actually, I might move this over a little bit so I can see what you can see properly. Yeah. So I've gone through and verified these waveforms, and yeah, they are there. I did have some notes somewhere about things. Where are they? I've got so many little notebooks lying around. Now, initially there's a bunch of things I thought were faults, but they actually turned out to not be. They were just the way it actually demonstrates those functions when you're doing the test modes. So it gave like a nothing on display and an out of range message, but it actually turns out that's normal for that particular range in the test mode. So those turned out to be fine. So most of my notes here are about things which I thought could have been wrong. Now I've got A5 board, which is Q9 and Q14. I've got these as question marks. So that is the A5 board that we're looking at right now. So we shall find the diagram, which is there. What did I say I was looking at? Q9 and Q14. There's Q9, just there. And Q14 is there. Right, so these two parts I got odd readings from. So what I did is I went through my multimeter and diode test mode and just probed all the transistors and stuff like that. And those two parts gave me slightly odd readings compared to the rest, right? Because these are identical parts. So having that, does my cursor show up on there if I'm doing that? It doesn't, does it? That's interesting. Yeah, that's a shame. How am I going to do that? Just realised my cursor didn't show up on the window display, so you can't see what I'm pointing at. I might have to draw on diagrams. I hope not. I'll have to figure something out for that. Anyway, so Q9 is smack bang in the middle of the board, right? If I, let's put it in the middle of the window. There we go, right? Smack bang in the middle is Q9, and I move it up, and Q14 is now smack bang in the middle. There, right? So those are the two parts I'm suspicious of. So Sasquatch, the op amps may have been overloaded by a charged cap. Possibly, yes. That is a consideration. So this is where the input comes in. Got that op amp here, U1, and it passes through to these MOSFETs. So what was this lot for? That was ranges or something, I think it was. That was range switching, if I remember rightly. So I mean, this op amp right here. I mean, that is certainly a suspicion. So I have done voltage checks around these parts, and I haven't found anything wrong. Just measuring the input voltage and output voltage, and trying to see what's going on there, and I haven't actually found a fault yet. I was suspicious about which one was it? I think it's U5B, which is in the middle of the screen about now. I was suspicious about that one because that adjustment I was having trouble with is on these offset adjustments, if I remember rightly. Might have been offset 3, was it? Might have been that one. Something around there somewhere. I'm just trying to remember now, I can't remember. Yeah, so it's in there somewhere. So I need to basically come through this whole circuit through here, this input stage, as you say. It could be a bad op amp or something like that, but I'm suspicious of these MOSFETs, this Q9 and Q14, so they give me strange readings. But MOSFETs are not necessarily the easiest thing to measure anyway. They don't measure the same way you can measure a transistor. You can just bang, measure it. Diode test mode gives you the junction values, and it's fine. You might see that 0.6 volts, 0.7 volts, whatever it be, and move on. You know, you can check it both ways to make sure it's not leaking or shorted. But the MOSFETs are not quite the same kettle of fish there. They work a little bit differently. So just the test voltages from the meters can turn the MOSFET on or off. So you can get some variances there. So yeah, I'm suspicious of them. I don't have any parts to replace those with at the moment. I don't think so. Anyway, I need to check. I do have a bunch of little MOSFETs, but you know, I could just try swapping. I could just swap parts and see if it changes anything. You know, I could like, swap that Q9 with Q10 and see if it affects anything. You know, if I get a different result, then I might have something to go by. You know, that's a method of troubleshooting if you don't have the parts. Swap them around and see what you get. Is U7 putting a similar ground? I did get a voltage. I was getting a signal here at TP3. I was getting something there. I was actually looking at Q20 because yeah, out of here, this 14L signal was looking a bit funny. Yes, that's a consideration being pulled down. JFET, well, yeah, okay, JFET's in. Yeah, I don't know. It's just JFETs, okay. MOSFETs and JFETs, that sort of things, are not things I normally work with. I mean, I've had limited experience with them, so if it's the wrong symbol, then yeah, okay, JFET. I'll take your word that you're right, because I don't know. It's a MOSFET. It's not a transistor. It's not a typical silicon bloody bipolar transistor. It's the other type, so that's fine. Oh, got a message held for review. Interesting. Why is that? No, that's fine. I wonder what that message is. It's held review. Let's try and look at what it is. Why has it done that? Hold on a second. No, it looks fine. I've got a thing there from Alberto, and it says the message is held for review. That's about JFET, not MOSFET thing. Maybe it's the next one down. Okay, maybe it's Sasquatch's one. That's right. It's displaying weirdly on YouTube. Sorry about that. I think I've just cleared that off. I think it's all right now. Because I think it's because you said tranny. I didn't like the word tranny, I think. Yeah, you can't read the tranny numbers. Okay, right. There you go. I'll get it a bit closer for you. There you go. Alright, so that's Q9 towards the top, and Q14 at the bottom one there. Okay. Bring it out slightly so you can still see it all. Yeah, because I'll certainly yeah, I also can't use the word, yeah. I think transistor would be alright, or tran might be alright. I think tranny was, YouTube thought it was offensive. I knew what you meant, but anyway. Yeah, so I need to go through this whole section of the circuit here and just figure out what I'm supposed to be getting and where. So I've done some tests around the op amps and they seem to be okay. The input versus output voltages seem to track, and the signals seem to track, that kind of thing. So I think they were okay. So I think I probably need to be looking at these JFETs. And yeah, and going from there. But I do remember the voltage coming out of here, well, the signal I was getting out of this 14L connection, 5R connection here, was something I was looking into. I do remember I was looking into it. I don't remember exactly what it was now. My memory is not what it was 10 years ago, I tell you. Yeah, I can remember every little detail about everything 10 years ago. I can remember everything, but now not so much. This is only a week ago and I've already forgotten most of it. Not good, eh? Anyway. So yeah, this is what I need to be looking into, I think, is this section. Let's follow up this other view. Let's do this one. And we'll probably have another play around with this, and maybe I'll chuck on the extended cards and do some probing around, eh? We'll do that. So you want the A5 card, so that is a 3, 4, 5 is that one there. So I'm glad I bought these extended cards because it would have been a real pain to work on this without them, I'll tell you. They're quite expensive to get for what they are, you know? Just a bloody edge connector and a piece of PCB, but hey, you need them and you need them. You know, the fact that I can get them at all was brilliant. Now, I'll try and plug these in. Oh, let's just drop this down so I can see what I'm doing. I did find them a little bit tight inside the actual ball connectors inside in the chassis. I ended up having to trim just a little bit off the edge of the cards. The cards are a little bit too wide. I just trimmed just the slightest little bit off them, and then that made them fit a lot better. So let's extend the card in there. Now, I was measuring around those devices here and these. I might have to pull up the board layout so you can see what I'm actually talking about here. Let's see what we can do. Right. This is going to give me... I need to do this somehow. Which is the best way of doing this? I have to shove up the side, don't I? This isn't going to work. Let's try that, shall we? Let's do it that way. Right. Board layouts. Can you see that? Just about. Yeah. Here we go. So it's not the best view, is it? Right, so U7, U8, and then U6, U5, and where's those transistors? JFETs. Here we are. So we've got. Trying to get them in shot if I can. There's Q9 at the top now, right now, and Q14 is a couple further down, just down there. So I'll probably get these in shot. I'm trying to get this window so I can see both at once. It's not cooperating very well. Right. Here we go. So there's the view there. So what I might do actually is just bring this up slightly more. And drag this down a bit more, so you can see a bit more. Right? Sounds like a better plan, doesn't it? Right, so I'm not quite sure which bit to start with now. So now I've hidden the bloody circuit diagram view. I don't have a printout of that either. Oh dear. Okay, so right, I'm going to go back down to the circuit diagram. So we've got U1. We'll look at U1 first, eh? We'll look at U1. And then we'll look at U2 and we'll see what we're getting on those, and then we'll go through these the Q9 and the Q14, do some voltage measurements on those and see what we get. And then we'll go through the U5 and to that TP3 test point there. We'll just see what we get. I mean, I don't know what I should be expecting without looking at the other references and in the diagrams and in the troubleshooting guides. But we'll just have a poke around. Maybe you guys will spot something which I've been missing so far. It's entirely possible. So let's bring this down a bit. Okay. So new ones, pin 2, 3 and 6. And you want look at all of you too, you think? That's offset stuff. I want to look at the main path that comes in. So we look at U1, follow through Q9. And yeah, we'll look at that, U1 through to Q9. We'll try those first and see what happens, eh? So 2, 3 and 6 of U1. Let's go back up, find U1, which is right there. I don't remember probing around this part. And I was probing around this in. Don't be doing that one. So now I've got to find out where pin 1 is. That's always interesting. There's a little dot. Now this package type confuses me, right? I've come across parts where the dot signifies pin 8, not pin 1. Whether it's a silk screen, well, a marking issue on a PCB, that's not on a fluke. I was finding pin 8 was marked. So I might have to try and just figure out this from that diagram. Which pins are which. Actually, I might just grab the actual part here. And put it in there. And let's try and see which pins I've had connections to and not. And see if I can trace it through that way, just to be sure. Cause the dot should be pin 1, but I've come across it being pin 8. Okay, there's 2 pins there which aren't connected at all, by the looks of it. So I think that is pin 8. Right. It mentions pin 6, doesn't it? 2, 3 and 6 are supposed to have connections, so if that is pin 8, then that would be pin 1. Where's it going that way? Oh. That must be 2, 3, 6 over there. So if that's 2 and 3, hopefully it's on camera, then that must be 1, that must be 8. Yes, 2, 3, 4, 5, 6 is that one, which I can't tell. Anyone got any ideas about which pin's which on that thing? I'm going to have to look at the diagram again, aren't I? Okay, hold on. There must be a way of doing this easily. Right, so 4 and 7 are power supply. 2, 3 and 6, so it should be 2, 3, 4, 6 and 7 have connections. So 1 and 8 do not have connections. Okay. I'm assuming I'm on the right card. I haven't got the right card out. Right, no, I've got the right card. So 2. So that big track there must be 7 for the power supply. So 6 must be that one that's going across there, which is linking to, what would that be, if that's 8, 1, 2. 6 and 2 linked together? Are they? Yes, they are. Cool, figured out. Right, so yes, in this case, The dot is pin 8, not pin 1. I don't know why there's a difference. It's a bit odd to me. Okay, so at least we've got that established. Alright, so what are we going to check for? Well, untangle my wires for a start would be really helpful. So, let's do some probing. Let's see what we can find. My clips are going to go on there okay without falling off. I don't want it falling off. Probably stick on there, which is alright. Okay, so that's 8. Then pin 2 is this one. I see there just about nothing, as you expect. Nothing there. Pin 6 is that one there. Nothing as well, but then am I measuring this wrong? I should try turning the bloody thing on first, shouldn't I? Okay, we'll try this again, shall we? Right, I'll stick it on manual external triggering, so it just says to flick around the ranges. Right, we'll try this again. Now we've got the thing powered up. There we go, we've got a signal. Okay. There's a reason it wasn't working. So that's on pin 2, which is a 1 volt signal, as you expect. Pin 3, same deal, 1 volt. So pin 6 should be the same because it should be going straight to both of them. Yep, it's fine. So that's what's going in. That one looks okay. Can't really fault that one. So U1 looks fine. Let's see if that was completely shorted out. But so let's go over to Q9, and I've got to find the thing here first. So Q9, and I've got to see what's going on here. So they've got the diodes on the gate, and the resistor on one side, and U5 on the other. So let's do some probing around there. This is more like it, you reckon? Doing some troubleshooting. Yeah. So, instead of me sitting here waffling. Okay. Q9. Right. It's right there in the middle of the screen. Now, that's the transistor N. I've got no idea what the pinout is. No idea. I guess I have to figure it out. So that's WQ9 right there. So what do we have here? Yep, 1 volt RMS. And nothing at all. I do have DC coupling on. I think I have. I should check that actually. Yep, DC coupling's on, that's fine. And that's gone right off the screen. There's a nice low signal there. That's 10 volts down. Been pulled down to 10 volts. So, what the hell are those pins? That's the next question. Let's have a look. Is it eBay special? Yeah, it is. As you may or may not know, I buy broken things and fix them. So, this is a broken thing. It wasn't that expensive. I think it was about a quarter of the price of a known to be working one. So, yeah, it should be a bit better. Now, what the hell is that pin out? So we've got This is not easy to see on this diagram here. I am having a real hard time making sense of what that is on here. It might be easy to look at the board. So those are the diodes, CR4 and 5, right next to it. So I can trace those through at least to give you which one of the terminals are. Which I think we're going to there. So I think, okay. Probably relying too much on the actual service manual for this. So yeah, the CR4 and 5 there, which go to that leg of that there, which is the -10. That's that -10 volts I'm getting on there. So that's interesting, isn't it? I've got a, on the other side of those diodes, I've got a, what's that, 2.8 volt or 2.4 volt, positive 2.4 volt on one of them. Alright. That one there is, yeah, 2.4 volt positive. That one there is negative 10 volt. So that one there, which is measuring that waveform at 1 volt, is going to the next device over, which is Q13. Back down to the diagram. Where's that going? Q13. So the top one of the signal was coming from U2B and TP1. Right, so yeah, that's fine. That's that signal as you expect. That's going into the device. I'm getting that -10 volts here. Nothing coming out. Is that what it's supposed to do? You know what it is? How's Mark doing? Has something happened to Mark? This is news to me. Mike, any ideas? I haven't heard from Mark for ages, actually. I'm going to sit and wait for an answer now. Pressure's on you, Mike. So, I don't know, now at this point now, well, is this right? We're getting a negative 10 volts on the output of Q9. Where's that coming from? Is that coming from Q9? Or is it coming from Q10? Or somewhere else? So maybe we need to test all these other diodes and see what inputs we've got on those. So we've got any leakage through there, because we've got that -10 volts on that gate. Oh, does that seem wrong to you? Is that wrong? Yeah, yeah. So it switches with the ones as required by that particular mode, that's right. Oh, well. Don't piss your cat off then, eh, Mike? Well. Okay, good to hear he's out of hospital at least. Wow. Yeah, cats aren't clean animals, you know. I like cats. I've got cats myself. I like cats. So, yeah, they you know, who knows where their mouth has been. You know, have you smelt the breath of a cat? It gives you an idea. So not surprised he got infected, but wow. Okay, good to hear he's alright. Okay, moving on. So where is that -10 volts coming from? That's just on the output of that Q9, which I keep putting off the top of the screen. Okay, I need to adjust this view, don't I? Hold on, let's adjust this view a bit more. Let's make this window smaller. So I've got the same view that you've got. Oh, with the right window, be good. Right, that'll do. Okay. So the question is, where's that signal coming from? So all these symbols here, these are the various mode inputs, which do switch these FETs for the various modes to route the signals through the various paths into it, assuming that slightly. Okay, so the various paths come through these, and are then joined back up again to go through here. And the fact I'm getting that minus 10 volts at this point, to me, seems a bit odd. I'm not sure that's quite right. He has a lion. Well, if it's trying to eat him, it might be, yeah. Oh, flesh eating. Oh, Jesus, really? Ooh, nasty. So yeah, we need to figure out where that minus 10 volts coming from. And the fact is that minus 10 volts on this diode, one of those diodes there, I can't remember which one it was now, feeding in. That's interesting. But it also feeds through Q10 as well, through this resistor divider network. You'll see a little divider there, that's ground. So that's dividing it down for a different signal range. And Q13 passes through to U6 and does some other stuff over here, wave shaping. This seemed to be working okay. I've done some testing on this and it seemed to be okay. Seemed to be, but I'm not sure. Right. So where do we go from here? The fact we got that minus 10 volts here is making me suspicious. I'm not sure that's what was meant to be there. Maybe I should change ranges. We'll test on that point there again, and do some range changes and see if we get anything changing there with that voltage level. We'll try that, shall we? See if we get a signal coming through or anything. So back onto there. Was it? No, the other side. To there, wasn't it? Is there? Have I got this right? Am I confusing myself? Maybe we're not getting 10 volts here. Hold on. I could be waffling on about nothing. Okay, no signal there at all. I see nothing there. If we go to series mode, or serial, sorry, series mode, get it right. Now I've got a waveform. So parallel, no waveform. Series, there is a waveform. Okay, so you think then that that's probably right then, don't you? Okay, let's check the input. And I've got a waveform on the input as well, instead of a minus 10 volts. Isn't that interesting? Why would the gate have a waveform on it? So that's 840 millivolts, roughly. Just double checking there, yeah. That's 930 odd millivolts. That's 840. 840. 930, 943. Okay, so no, I think that's probably right. I don't think that's faulty because you got different voltage levels on each pin. But is that being sourced from over here? No. No. Why is there a voltage on the output of the gate? Does that seem funny to you? Anyone got any ideas? Should there be a voltage on the up at the gate when you got it passing through the device? I'm not sure it's right. Let's try some other tests. Let's check the device next to it. That's also got a nice 10 volts on there again. Parallel mode's got a waveform on there. Okay, so it is seemingly doing the same thing on the device next to it as well for the other range. So maybe I'm being a bit paranoid about that. I'm just poking around, I'm just taking guesses here. See what we find. You never know what you might find. Those ones aren't doing it though. So we're looking at here did I follow troubleshooting page 148? I've gone through lots of troubleshooting stages. 148. 148. Hold on, 148 is higher up. So 148 looks like it might be the one I've already looked at. Isolation. 152 I've got there. And I did last isolation. Yeah, I've looked at all this stuff. Yeah, from that point, that troubleshooting stuff, I've looked at that, and I didn't find anything. At least not yet. I haven't exhausted the entire process, but I didn't find anything. But I'm suspicious about the way a couple of things are working. So back to this. So I'll look for. Oh, gosh, jumping around the wrong place now. Yeah. So Q13 was acting the same way as Q9. Okay. And Q13 is here, towards the bottom there. It's right at the bottom there. So, same input, different source signal. I don't know. It's a bit inconclusive. What's wrong with the meter? It doesn't work. I'm off to snooze a fland. Okay, thanks for visiting, Brian. Good to have you. Enjoy your sleep. It's hard trying to find a time of day where it's suitable for everyone that watches, but obviously about it's like 8 or 9 o'clock in the morning looks like an optimal time for that, so I'll try and get those a bit earlier in the future. No, it's not measuring the device under test. No, it's not actually. It's detecting there's a device there, and it's auto-ranging to try and take a measurement, but it's not actually taking a measurement. It's not generating an actual measurement reading for it. 843 and 845. Yep. Yeah, I did look at those procedures originally. I did go through that process, and I spent a lot of time going through those. When I publish the actual videos I've already recorded for this device, you'll see that I was going through that procedure already. But obviously something somewhere is not passing the signal through for it to auto-range correctly. Maybe it's auto-ranging incorrectly, so it's doing the wrong range, and then it's realising it's in the wrong range, and it switches back, and it's just maybe it's a DC passing through or something like that, which it shouldn't be passing through, so it's confusing it. I'm just speculating. I don't know. So let's look at the U5. Let's do some measurements on here and let's see if we get anything odd showing up on these pens. So we've got make it big enough so you can all see it. So U5. I know the power supplies are okay. I've already checked all that stuff. I know that's all fine. Thanks, Brian. I'll try and do more live streams now. Now I've got a proper camera set up and I've got this little webcam thing going too. I'm actually a bit better set up for doing live streams, so I might actually do more of them. As long as I've actually got something to talk about instead of me waffling for half an hour. That's the plan. Alright, so U5, it's one part which does the whole sections, A and B section, so it's obviously a dual op amp. So I need to measure pin 3, 2 and 1 for that first section, and then 6, 5 and 7 for the second section. So 1, 2 and 3, we'll look at those first. Now U5 is where? U5 is there. Okay. Zoom in more. Oh, probably might be too big, but so we find it. There we go. There's U5 there. So easy enough. Let's go and have a look at that. So what did I say I wanted? 1, 2 and 3, was it? I've forgotten again already. I think it is. Okay. Yep, 1, 2 and 3. Okay. Right, see what we got. So there's pin 3. We'll check the inputs first. We have a waveform, which is about 940 millivolts. 2. We have a chopped off square triangle wave. Is that trapezoid wave? Trapezoid, is it? That's what it'd be called. That's about 780 odd millivolts, jumping around slightly. And pin 1 is a big output, so it looks like it's amplifying just fine. Should go a bit more. Yeah, so it's amplifying that trapezoid. And that's doing 8.35 volts output. So the first stage of that looks like it's amplifying just fine. Yeah. Okay. So look at 5, 6 and 7 next. Well, 6 should be pretty obvious because it should be the same as 1. So let's just move this probe over here. Okay, so actually I probably don't even need this, to be honest. It probably works fine without it. It's all ground reference anyway. See, ground, no difference. I'll just take it off. Alright, now. So 6 is obviously that 7.9 volts. 7.9 volts. Hold on a minute. .35. Pin 6. Get on there without slipping off, it'd be quite good. 7.9. Why is there a difference in voltage? They should be connected together. Am I doing something silly here? 8.35 volts. 7.94 volts. What? Maybe it's got some other noise which is being filtered at that point. I don't know. Definitely 8.4 there. 7.97. There's a voltage drop between that point there and that point there. Doesn't that seem interesting? Oh well, carry on testing, we'll see what else we can get. So if I don't reply to your comments quickly enough, I'm kind of looking at the screen occasionally when I remember to do it. I need to get used to this live streaming thing. Okay, pin 5, that's 8.4 volts there. Okay. That's interesting. Is an error on the diagram? It looks like 5 and 6 swapped around in the diagram. Because 5 has got the correct signal, was 6 doesn't. I'm going to have to look into that. Okay, pin 7 is fed back into 5 apparently through a resistor, so it should be the amplified output or something. Get an 8.36 there. Something interesting is going on here, isn't there? Something's not right. This doesn't seem quite right. Am I dropping frames again? No, I'm not. Just checking my stream. Looks like my YouTube playback is seemingly frozen up. I'll just refresh it. Hold on 1 second. Let's just reload that page again. Hopefully it all works again. As I was saying before, the problem with being on wireless broadband is it's not necessarily a nice stable thing. Okay, yeah, it seems working. Right, all good. So, something's interesting here, eh? That's not what is on the diagram. So let's have a look at this in a bit more detail. Pop the card out. Most of it out. So yes, pin 5 is looping around to pin 1. So I'll put it right around so you hope you can see it. I can't see what you can see at the screen. Is it going to focus on that? Hopefully. I'm not sure what this focus is going to be like. Hope it's too bright. Maybe that's about it. Probably his camera trying to get the range right. Anyway, so you can see there's a track that loops around, comes back down to here. So that's pin 1, that's pin 5. So yes, it's looping back to pin 5, not pin 6. So the diagram has got a different designation there. So that's interesting, isn't it? Why is that? You know, maybe it's a revision, maybe it's not the same part, I don't know. It's got an HP part number 18260139. Yeah, that's helpful. I have to do a look up because a lot of these HP parts do have cross references online where you can actually find out what they really are. Not all of them though. There's lots of parts you can actually find, but yeah. So pin 7, I was expecting that to be amplified, unless I'm interpreting this incorrectly, which is certainly possible. Go back in again. So yeah, interesting. So, what's going on here? Obviously, these are incorrectly marked. I might need to find out what that part is actually, and I might just swap it. Seeing as the input is the same as the so pin 7 and 5 should be different to each other. No, it's feeding back to 6, isn't it? 7 should be more than 6. Now this is getting confusing. So that's 5 there. 6 has got this circuitry here. Yeah, okay, so that should be amplifying, but it's not. Is this it? Is this part of the problem? Right, so we'll find out what that part is. Let's get a new tab open and go HP. Part number, what the hell was it? (1826-0139). 1826-0139. Let's see if we can find it. Oh, XDevs. XDevs, yeah. Cool. Let's look at XDevs. Just waiting for it to come up. There's also another cross-reference here. Okay, I might move to a new window and drag it down so I can see it, so it's not looking up above my head all the time. Right. Right, what am I looking for? I've forgotten what it was. 1826. Does it show it? And it's a picture, so I can't bloody search it. That's awesome. This isn't the XDevs one, this is another site I'm just looking at. It doesn't seem to have that there. Oh no, here's a different section. 1826 0139, not in that list. Let's keep looking. We've got a few lists here. That's probably not very exciting for you, but if I find it, I'll show you it. This site's not looking promising. This is searchable. Hold on. Okay, this second section is searchable. Right, 1826 0139. Aha, okay, right, found it. Aha. Right, let's see if I can pop this up in the window viewer. Let's see if I can add this in. I'll put it in Studio first so it doesn't swap it around automatically, but I'm still trying to modify it. Window capture of what? Source will be Safari cross-reference. Here we go. We shove this in here. We'll stick this over the top of that and I'll show you that. Position it. Here we go. Now this is try and make this a bit bigger, shall we, so you can see it a bit easier. Right, so this is what the crossref comes back to for that part. There's an MC1458PI. Okay, standard op amp. Standard op amp, not a problem. That's easy to sort out. I expect I've got some. I probably do have some actually. So that's all cool. Get rid of that again. So I might look at replacing that part just out of suspicion. Now I can't see what you guys are saying because I've clicked away from it. Nothing, no one's saying anything. Okay. And my stream's still playing up a little bit. Might have to reduce the quality very slightly more. It's struggling with that frame rate. Let's just reduce it slightly. It's only just keeping up the frame rate, so hopefully it'll be a little bit better now. Okay. Do I replace that part? Well, I've got nothing in here. I'll have to go and find one. Where do I have them? So I've got lots of parts drawers still in my house on the walls. They're mounted on the walls, you see, so they're out of the way from the work that's being done. Let's check my spares box. Hold on. I might have some in there. Let's see. Find the things, transistors. I've got bags and bags of stuff here. These are things that I have a box which I'll keep just for my spares, like you see. Okay. These are parts which are for specific repairs or for specific pieces of gear. So a lot of these are fleet parts. But I do have some HP parts in here as well. So But generally, anything which is for a specific piece of gear, I'll chuck it in here. So if I have to replace it, I know where to look. So I've got lots of these. Well, I've got these. Oops, I don't even see these on there. Probably not. Get it on camera. You can see that switcher. See how switches in there. Hopefully, get it in silhouette. Those are for the record Dana counters, frequency counters, replacing switches, things like that. You know, like metal transistors and op amps and stuff like that. So these, yeah, I don't know what the hell they were. but yeah. Looks like I don't have any of those in here. LM301s, LM318s. Yeah, I haven't got any here, so I must have in the house if I've got any at all. I don't want to leave the stream running when I go hunting for them, so I might not replace that just yet. Okay, JFET will allow U5B to have 1 times gain or 25 times gain depending on the logic state via the diode. That's helpful, thank you. Yes, because I'm getting 1 times gain right now. Okay, cool. So that might be okay then. Might be looking for that part for nothing. How's the flute repair going? Will I calibrate it eventually? Well, I've got a part 18 which is uploaded to YouTube already. I just haven't released it yet, which shows its current condition. Oh, start watching because of the blog. Really? Okay, cool. Welcome. And the fluke is mostly working. It is generating voltage. It is working through all of its ranges. It's 95% there. It's just got noise in the output, which I think is related to a frequency control error. So if I reduce the frequency to below, I think it's about 200 hertz or something like that, 150 hertz, I think it might have been, then I'll start to get glitches in the frequency generation. So if I'm trying to do a 50 hertz signal, it's got lots of noise in it, and it makes the voltage jump up and down. It's nowhere near as stable as it should be for a calibrator. It's all over the place. You'll see it on the videos when I publish them. I think I've done a little bit of it on part 17. I think I showed something there where it shows the output stability is not very good. It's jumping up and down, you know, quite rapidly. I believe it's due to frequency issues rather than voltage issues. The voltage is a result of the frequency because that's the base of what the whole unit runs from. So it has the internal crystal oscillator in there which runs on it, which generates all the frequencies. It runs the counters, and the counters then divide that down to generate the frequencies you want to get from it. And it may be a glitchy IC. It may be an issue with the actual frequency source itself. So I need to narrow those down some more, but right now I'm having a break from it. I've just had enough of it because I've been working for so long, and so it's a bit of a pain. So I've just given it a bit of a break. I've still got it here. I mean, it's 95% there. It's just I just need to get that noise down, and once I get that noise down, it'll be done. But trying to source exactly where that's from, because it's a completely closed loop circuit, and there's not one loop. There's more than one loop, and so if you want to troubleshoot a section, you can break that loop, inject your own signal or detect your own signal, one or the other, see what's coming back or see what's going in, or also put your own signal into it so you know what's going into it, and then see what's coming out, to narrow down where the fault is. Now I've actually tried doing that on the fluke, and it didn't like it. Even though I was injecting a signal like it was expecting on the, I think it's the AC to DC converter board I was trying to intercept into. So the feedback from the amplifier into the AC to DC converter board is where it monitors what it's doing. I tried substituting that with my own signal, and it didn't like it. It just didn't work. So I need to actually look into that in some more detail. So if I can interrupt that loop, I can determine if the noise is coming from the amplifier or the frequency generation side of things, the oscillators, that sort of stuff. So that's where I'm at with that right now. But I'm just having a bit of a break from that right now. It's just doing my you know, you get to a point where you get a bit stuck, and sometimes when you get stuck, it's best to put it aside, leave it, and then when you feel like it, go back to it again and carry on. You know, because that fresh start it just restarts your thought process. You get stuck in a rut of thinking it's one thing, where you may be you're focusing on the wrong thing. It could be something completely different. And I find doing that, just putting it to one side and leaving it, if you can't always do that, can help. You know, because you come back to it with a fresh thought process, and you can be sometimes, you know, you find a thing you're overlooking before. Anyway, so back to the HP. This is driving me nuts too. So U5B looks like it's probably okay then, because it's saying it's potentially one times gain. So, and that's what it's doing. It's doing 1 times gain. So we can move on from that. So over here, we've got this device here, the SAT detector, which is saturation detector. I think that's what it stands for. I haven't looked into how this works. I could do some voltage measurements, couldn't I? So which is U7, which is one of those metal can devices, if I remember rightly. Yeah, metal can. Here we go, some more. Signal to U5A is provided via the 4 JFETs that form analog mux. To find which one of the 4 inputs is active, the logic gate states that the 2 diodes at each FET need to be checked onto, if I recall. Yeah, that sounds right. That sounds exactly right. Yes. Because it isn't working on any mode or any range, I believe it's an overall fault rather than just a individual input fault. So I'm trying to check for the more major parts where the things feed through it, which is what this bit here is supposed to be. I want to zoom out slightly. So yes, these are obviously input sections and selections and ranging, and then obviously all of those have to pass through these, which is why I was suspicious of these. All has to pass through these, and this saturation detector thing, which also splits off here, but that's actually a power supply input. Now if you look at this wave shaping section, it's got a minus 12 volt signal here, supply here, which then goes through a 6.9 6 volt, yeah, 6 volt Zener, which then drops it down to 6 volts, coming as a supply for this saturation detector thing. So that's just that's purely a power supply for this section, so you can ignore that path. So as long as you've got power supplies in, you've got this grounding, you've got the input and the output, then you know it should be a fairly simple thing to actually troubleshoot. But I haven't looked into this part myself yet. I'm not sure if this is an issue. It may be. So we can check this. We can check this right now. So we want U7, and it's because it's got these looped together, it could be a little bit interesting. So that's obviously push-pull, effectively a push-pull system, if I'm interpreting that correctly. So cool. I take it Hillmouth. Is that how you pronounce it? Hillmouth? Hillmouth? I'm not sure. You can't exactly tell me how to pronounce it, can you? It's a bit tricky. So Hillmouth, yeah. I'm presuming you've got one of these and you've worked on one of these yourself previously. It seems you've got some experience with it, which is going to be helpful, I'm sure. So we'll look at the saturation detector thing. We'll just check that. As soon as we know it seems to be working up to that point, and we'll see if it's that. But I was suspicious about the transistors there. Yeah, Q20 is one I was looking at. Q19, Q20. I was looking around it before, but I can't remember exactly what it was I was looking at there. There was something I was suspicious about. So we'll look at these. So pin 3, 4, and 9. We'll look at that. We'll treat it as 2 separate devices. They're tied together. We'll treat it as 2 separate ones, and we'll see how it looks. All right, 3, 4, 9 of U7. which I think was the one closest to the bottom of the board. Yes, it is. Okay. I've lost where it is. Here we go. Right. Let's see how we go. Right. Which pin's which? I mean, they're laid out as a dip package, but it's 10 pin device. There's pin 1 over there, or there's a dot. So I'm going to take that as pin 8, not pin 1. Okay, so, and my stomach's rumbling, I need to have something to eat soon. It's midday already. Wow. Okay, so 3, 4, 9 we need to look for, so let's assume this is pin 3 over here. I'll turn it back on first, that'll be helpful. Don't want to make that mistake again like an idiot. Get on there, stop slipping. I think this tips is a bit blunt. So I've got a little bit of voltage there, not much. It's about 900 millivolts. Let's scale this up slightly. That's pin 4. There's that trapezoid wave. So that's 1.45 volts. So pin 4 is what's coming from that other point. So yeah, that's what we kind of expect. And pin 3 is supposed to be a voltage. That's a voltage divider, effectively. So it's almost 10 to 1. So it should be about a volt, roughly. I mean, I'm just doing it in my head there, just very vaguely. And yeah, so again about 840 millivolts, so that looks okay, the input side of it. So let's check pin 9. Now, so it's 10 pin device, so we shall try and get into there with it. And that's got a DC offset. But the waveform's there, so it looks like that's probably okay. So that's doing 4.2 volts RMS with a DC offset, or you could say it's TTO level, couldn't really. So that looks okay. So I'm just reading the comments there. Okay. Ah, how much? How much? Ah, right. Okay. 50 years background of electronics, yeah, you're a bit far ahead than me then. A bit further ahead than me. I've been doing it since I was 13, pretty much. Well, I was actually playing with electronics when I was 7, is when I started putting apart old TVs and things like that and taking the components out and desoldering stuff. But as it comes to actually thinking about how electronics work is probably from like 13 onwards. So you're quite a way ahead of me. So good on you. Yeah, it's very helpful so far. So probably saved me going down the path I didn't need to go down. So okay. So you said maybe an open collector conspirator. Do you mean comparator? Do you? Does look like a comparator, doesn't it? That's the outputs. Or deed. I'm guessing that's a typo. Oh, I don't know. I'm not sure what you mean by that, but that's okay. Alright, so pin 9 was amplified DC offset. Okay, right, so that's fine. So we'll look at the other side now. So you want the pin 7 and 6. So that's pin 6 there. So that is a negative 800 millivolts or so. Does that look about right? Thereabouts. Logical, yeah. And then we've got 7, should be the same as the other one, so that's fine. Yeah, okay. Well, I think that's working okay. I think that's right. Or should it be referenced around 0 volts? That's the next question, actually. I should probably analyse that some more. So you've got the 9 volt there, right, which is obviously base of 0 volts, go up to 4 volts. Alright, so, but because it has that supply there, oh no, that's fine. Its power supply is based off of, it's based off of a ground reference anyway, so it should be fine. Yeah, no, that's right. I think that's working okay. Cool. So I think U7's alright based on those tests. I think it looks fine. Unless I'm interpreting something wrong there. Because it's got a ground reference at this pin 5 here. It's got a 12 volt supply into this side here, into that reference. Well, it's not 12 volts, it's 1 volt or so coming to there. And it's got 12 volt supply into pin 10. Minus 12 volt going through this voltage divider here as well with the pin 6. So we've got voltage divider pin 6, voltage divider pin 3, which is doing a negative supply, so that is being that's ground reference there. So that is a negative pull down, positive pull up. So yeah, that seems to be okay. So I'm confident that that part's alright based on how that looked just then. So we'll look on at Q19 and Q20. Let's see how we go with those. Let's find where they are first. Q19 and Q20. This Q20. Is that 19 or 18? I think that's an 18. That's definitely Q20 there. So my stream is not behaving on my computer. I'm dropping frames again. I think I am. Yeah, my rate's dropped down again. I'm going to drop the quality down some more. As obviously as people are using the internet today, my streaming ability is getting worse and worse. Eventually I'll find a point where it stays stable. Okay, so Q20 is there. I think that is 19. It's got R176 right there, so we'll look for that. So R177, R176. Sorry, R77, R76, get the numbers right. Let's double check those. Should zoom out first, it might be a bit easier than that. Alright, so oh, have I gone too far? I think I have. Hang on a second. Where is it gone? There we go. Right. From having the window minimised so much, I've got the same view that you've got. Okay. My stream seems to have settled down again now. Seems to be. Now drop that quality down slightly more. Okay. R76, R77, so yes, that is Q19. That's fine. So we'll look at that. We'll see what we get. And now I don't remember which ones they were again. I think it was these two here. I think it was those two. You've got a common connection between them, which goes to a resistor. No. I'll have to look at the layout again. I'll look at the wrong ones. Alright, so let's try and remember this layout, shall we? So you've got gate to one side, gate to the other side for those resistors. Those resistors are across those. One across the input, one across the ground side. Okay, I'm trying to memorise this so I remember what I'm doing. Ah, okay, right. Alright. It's these ones here. There's a different style of transistors, so it's like a, I don't know, like a bead, I suppose. So that's 19 and that's 20 there. Yep, okay. Helmet, yep. Yep, that makes sense. Thanks for explaining that. So that what helmet says is that it should be how can I reword this? I can't really, can I? The 22k to 1k dividers give the limit thresholds to the comparator for the input signal must remain within these positive and negative limits. 12 times 1k divided by 23k, approximately 1 volts, plus or minus 1 volt limit, else appears saturation detect. Yes. Yep, I'll agree with that. But then you'll probably understand more about it than I do. So what you say sounds correct to my limited understanding. So there we go. Now we're at we're looking at Q19, Q20 down here. So we've got the resistor there, it's supposed to be across one side of it, so we'll try that first. There's a big signal on there. So that's that trapezoid again, so it's 8.35 volts. Got the other side there, which is nothing at all. And we've got this side here, which is hard to get to. There's a 11.3 volt signal there. Well, there's a signal there, but I should say it's got a DC offset. It's not actually 11.3 volts because it's got a big DC offset on there. But there's something. So that's interesting. Now, which pin am I looking at there? Can I determine where those were? I'm trying to see. So the middle leg is going out of the board. So that was that feed out to the board. So that's the another text message. What's this? People at work tell me people are sick. That's fine. I'm not there. I don't care. So 8.35 volts there, reference around 0 volts, that's fine. And my stomach is going crazy. Right. And we've got that signal there. So let's just can I see what those without having to turn the DC offset off. So we've got a 1 volt peak to peak. Okay, that's what we get in there, apparently. Yeah, 1 volt peak to peak signal on that waveform, which has got a 10 volt. Is it 10 volt? Yeah, 11 volt RMS offset. Yeah, 11.3 volt offset. Okay, so let's look at the next one. Nothing there. Nothing there. And nothing there. That's interesting. I think this is why I was getting some pictures of it last time. Hi Ray, how's it going? So let's go back down to the diagram. So look at this. So there's that Q19, which seemed okay. So we had that the output had no signal on it, which was the interesting part there. Also Q20 has got nothing on it either, but I think that depending on what range it was in and states and stuff like that, so it may be that's turned off currently, so it's not going to be doing anything anyway. It's got a ground reference on one side, so one side's definitely going to be off. Q19 isn't passing anything through. Maybe that's what's going on there. So that's why that's got nothing there, and obviously this has probably got no signal going to it right now because it's not being used. So I'm looking at Q19 now. Q19 is looking suspicious to me. Let's look more closely at Q19. So we've got CR20, which has got a feed into it. So we know that the middle pin is the output, so there's nothing coming out of there. Absolutely nothing. Let's change ranges, see if anything happens. See it spiked there, see that little spike there? So if there you go, I've got it changing ranges, and it says turning it on and off. Alright? That's a series mode, which is the nose, and that's the parallel mode, doing that waveform. So it's two different waveforms coming out. So there is something passing through. So it's probably just a mode thing, where it's not turned on. I'll do a manual triggering. We'll try and get it onto a range. So it's only when it's changing ranges is when it's popping up. So that's the input signal, which is there, and the output is only pops up as I change range. Or I'll re-trigger it rather than changing ranges. It's like triggering itself, and that's what's happening on the input, which comes from that diode. Same thing. So it's low unless it's triggering. It's like a trigger input. This is going to take some investigation. So let's do a single capture, and we'll do some comparisons on the output and the input. Maybe this is shorted. Maybe I'll just do normal captures so I'll keep re-triggering it. So that is 4.8 volts, 4.7, 4.8. Save again. 6.6. 4.8 again. Though when we're getting different voltage readings, if I'm getting, maybe it's to do with the triggering point. Interesting. Anyway. If I just look at the peak to peak voltage, maybe that'd be better, right? So that's 15 volts all the time, peak to peak. 15.4 volts. So if I look at the other pin here, using phone keyboard, yeah, that's fine. I'll read your comment in a second. Hold on. Check the zero logic levels. W19. Yeah, what? I understand what you're saying about the keyboard. W20 will be off if 0 is negative, and W20 will be on. So Q20 should trigger on negative. Okay. Well, we'll look into that in a second. So I'll just do comparisons to make sure this isn't shorted. So that was it 15.4 something, wasn't it? 14.8, 15. There is a voltage difference. 14.8, 15, 14.8. As long as there's a voltage difference, I'm confident it's not shorted. 15.4. Yeah. I don't think there's a short there, so I think that's probably okay at Q19. So Q20. So Q20 show trigger on negative. Where are we going to measure this? Okay. R177 and diode junction, where the diode junction is. We'll do R77, we'll go from there, eh? Junction of R77, which I think is that one there, potentially. That's positive, and as you can see, pulsing. Was it just me with a bad connection? Yeah, better connection. Alright. So I'm pushing the trigger and it's staying positive all the time. It's always at 3.5 volts. In that range. Let's try parallel mode. Nothing changing there. Okay. Changing ranges or changing functions, voltages. Yeah, that's not changing. Frequency, not changing. So that is always high. So let's check the other pin. I'll read your comment in a second. Okay, so I've got something wrong there. That's doing something, isn't it? That's what it's doing. Pulses. When I do a trigger, it does has negative pulses. Just there. So it might be on the wrong pin of this device. That's what. There you go. There's pulses there. That's what's happening. So there is something happening there. On two of the legs, anyway. Right. Let's have a look. Yeah, okay, yep. That sounds right, helmet. I understand that. That's looking correct. Yep, O and not O, yes. So yeah. Based on the fact that we're getting signals passing through, like this is triggering, as up from what I saw just now on the scope. That is functioning to a degree. So yes, that's pulsing that output because that's always tied low, so that's fine. So yeah, those are both working. I think that's the end of that path, at least for the time being. Right. Well, it's been going for 2 hours now, the stream. Wow. Yep, Q20, yep. Okay, well, I think we've eliminated some of the stuff anyway, so that looks like it's okay. That is switching. This appears to be switching okay. This is working. This is obviously switching this here somehow. Maybe it's the level adjustment because it's effectively a voltage, a resistance, a voltage divider, depending on how this is turned on. So we're going to be 1 or 23. He said, yeah, that's right. Yeah, that's right. He did say that. So 1 or 23. That's correct. Depending on what this is doing. Yep, gotcha now. Okay. So yeah, that looks like it's probably right. It's passing straight through, which is probably fine for some modes anyway. In fact, the no modes or no ranges work means it's probably in some state or other it's going to be in the correct state, so it's not going to be that. But I'm thinking about wrapping this stream up. It's probably getting quite late for some of you, and my stomach is growling. I really need to go and have some lunch. It's 12:30 now, and I'll play around with this some more and get my head around this a bit more and get a proper troubleshooting thought process going. You know, getting my head into the right space for a logical method of checking each section, because right now my head's not there. I'm starting to get in there now, so I haven't touched this in a week, and it looks like we made some progress. At least we've eliminated some stuff here, which is always good. Ray, I'm working on a HP4261A LCR meter. I don't think it shows up in the stream right now because I've got it showing the diagram a little bit, but I'll bring it down a bit. There you go, that's what it looks like. So I've got some video coming up for this. I've recorded a whole bunch of footage already on my repairs for this, and I just haven't put it into a video yet. And I thought I'd just do a live stream, play around live streaming, and yeah, so far so good. It seems to be quite stable. I'm having a few issues with losing packets of data and slowing down, and it's doing it again now. My stream rate's dropped down to 2.5. Let's drop it down some more. Let's go 3000. So this is going to reduce the resolution of the video, I'm afraid, but it should hopefully help it to behave a little bit better. Hopefully. Yeah. So yeah, I'm playing around this. I've got a whole bunch of video recorded for it. So I might do another live stream tomorrow morning. Well, tomorrow morning for me. So about tomorrow, about 3 hours earlier from now. Sounds about right, eh? About 9 o'clock in the morning for me. So whatever time it's right now, 3 hours before this tomorrow, I'll try and do another stream then, and hopefully I'll have my head around this a bit better by then, and we can make some more logical decisions along the way about which bits we should be checking. Because right now I'm a bit all over the place. I'm just sort of taking stabs in the dark right now, just trying to get some semblance of logic. So okay, thanks a lot guys for watching, and hope you enjoyed it a little bit and a bit of insight to what I'm playing around with. And I'll try and get some video up for this thing already, so you can see some background. I might actually get that done today as well. Actually, try and get that uploaded, so you can see what I've been doing already with this thing. Give you some idea. Okay, catch you later. Thanks for watching.